In this segment of the lecture, I want to talk to you about three things. So we're going to talk about comments in Sass, then we're going to talk about procprint, and also a little bit on procsort today. So let's start with comments. One of the advantages of writing a program is that you've got a complete record of everything that you've done. So if you're in a point-and-click environment and you point and click at stuff, then you don't really have a record. Whereas with the program, you've got this recipe that's spelling out all the steps in the order that they're to be performed. Sometimes, though, just having these steps written out, it can be kind of confusing, and you want to add some comments to yourself to help you remember what you were doing in a chunk of code, or to help you remember what a particular Sass program is trying to accomplish. And programming languages accommodate this need for comments in one way or another. So in Sass, the way it handles it is anything that is put between a / and a / is a comment. So Sass will ignore everything between those. It's just a note to yourself. So a little reminder that this is what this chunk of code is doing, or that's what this program is doing. A good practice is to use flower boxes. So what is shown below is a flower box. You can put this at the top of your program, and it describes what is the name of this program or this macro, what inputs does it take, what outputs does it take, who wrote it, and then when was it modified. So this is really good programming practice to keep such a log, and believe me, once you have 50 Sass programs sitting in a folder, you're not going to be able to remember what does this one do and how is it different from another version. So having these flower boxes will save you a lot of time in the long run. Let's move on to procprint. So I like to think of Sass commands as being something like Christmas trees. So with a Christmas tree, you've got the basic structure, and then you can hang all sorts of stuff on top of it. And that's exactly what you have with proc. So you can add all sorts of options on top of these commands, and they cause it to do different things. So we're going to go into depth on procprint and just see how options sort of work, and this will give you a good feel for how options work in general. So if you can kind of master procprint, which is a very simple procedure because it's really not doing anything other than displaying the data, then that understanding is going to carry over to other procs. So when you want to use regression and figure out how to do a stepwise, well, it's going to be an option somewhere, and you'll feel confident exploring those. Okay, so far we've had just a very basic procprint. Now this is about as basic as it can get, with one little exception. I did add this obs equals 10. More on data set options later, but this is asking Sass to print only the first 10 observations. So if this is a very big data set, we don't want to look at the whole thing. We can add all sorts of ornaments to this basic structure, and so today I'm going to cover all of these, from the var to the ID to the by, and so forth. Before I get into that, let me show you how to get help. So Sass has excellent online help, and if you just Google it, so let's go over to a browser, and I'm just going to Google Sass procprint. And once you bring that up, it brings you, they've optimized the search engine so that you are brought right to this wonderful help page. And so down here, you have everything you ever wanted to know about procprint and more. The one that I usually jump to first is the syntax. So I always look for the syntax, and this gives you a list of everything that you can possibly do. So we're going to talk about the by statement. We'll talk a little bit about ID, sum, var. You'll see that anything in the angle brackets is an option or a keyword. So what options can you put? Well, here they are. If you actually, I guess, where are they? Not sure where they are. If you go to the procprint statement, I guess here are the options. So you can put the data equals, so you can read about all of them: blank lines, double spacing, headings, and so forth. All right, so that's how you get help. And again, you can click on any one of these statements, and usually you get a description and some example. In this case, you don't get an example because it's pretty simple. Let's go back to the course packet, and I'll show you some of my examples. So here are some of the different things that we might want to do with print. We might want to just print certain columns. Maybe we don't want all the variables. Very often when I have survey data, I have a couple hundred variables in the data set, and maybe I only care about 5 of them. Then I'd use a var statement to restrict the columns. ID is going to cause SAS to print this variable on every line. Now, if lines exceed the page size, SAS will have to print them twice. So they'll print the first 5 variables on one line, then it'll print the next 3 variables in the next line. If you want to keep those linked, you stick an ID statement in there. So ID is very useful. We'll see examples of by, so it breaks up the output by these variables. Another very useful option. If you want to restrict which rows are printed, you're going to use a where statement. Sum adds up the values of a variable. Likewise, a sum by. Format's going to control the way that variables are printed. Now, 3 of these have a footnote, so by, where, and format. And the footnote reads that you can add these to most procs. So that is very true. You can add a by statement to just about every proc that I can think of. Likewise with the where, and likewise with the format. So just keep that in mind. So when we're doing proc reg, you can easily slap a by statement on, and it will have a very similar effect to what it's doing in print. Okay, let's just get a little taste of how these things work, and then we'll go into more detail on it. So the example at the bottom of the page has modified that little basic print statement. We're using that data set that we created in a previous video, employee. Actually, I'm using example in this bottom one, which we created in a previous video. So in this proc print, okay, so I say proc print, data equals whatever, semicolon. I'm going to add a var statement. So the var statement says I only want to look at name and income. So you'll see the output off to the right has only name and income. It also gives us an observation number. The other thing I've done is I've said, give me the sum of income. So what the sum of income statement does is it adds this, this total. So it gives the double line, and then it adds these up, and you can check it in your head. Sure enough, the total is 350. The other thing that I've done is I've changed the format for income. So I've said I want to display income using a dollar format. So notice what's happened to my incomes over here. They all have dollar signs in front. I've also said 8.0. So what 8.0 means is I want 8 characters and 0 decimal places. 8 characters, 0 decimal places. So you're going to see that the width of this field is 8. There are 8 equal signs. So I could accommodate a number that had up to 8 characters, including the dollar sign. The .0 says I don't want any decimal place afterwards. And so sure enough, there are no, it's just dollars, so we don't get any cents on that. All right, so hopefully you get a sense for how these options work. You just string them after the proc print and before the run, and you modify the output accordingly. So let's go to the next page and explore format a little bit more. The way you use a format command is you just say format, you list all of the variables that you want to have that format. So you can list more than one variable. You could put 5 variables here if you want. You could put 100 variables if you want. And then you specify the format. Now there's a whole chapter on formats in the SAS language manual, and you can, we're going to be exploring them in a lot more detail. In addition to these predefined formats that SAS offers, we're going to be learning in the next week how to define your own formats for things like marital status. If you want 1 to equal married, 2 to be divorced, 3 to equal single, 4 to equal widowed, you can define them. So it's kind of like a value label in SPSS. Just to get us started though, I'm going to tell you about a few. One is best. So best just is going to pick the best method for displaying a number. SAS will guess that. Comma, notice what happens to commas. It puts in a comma, at the thousand, between the hundreds and the thousands digit, also between the 100,000 and the millions digit, you'd get commas. So you say comma w dot d. So this is going to be the complete width of the field, the number of decimal places. So this would be something like comma 8.2. So the dot 2 would say I want 2 decimal places and I want 8 total characters. You can also use dollar. We've already met that one. So this would probably be something like $9.2. Percent adds a percent sign. And in general, w.d controls the number of decimal places as well as the width of it. So let's look at a few examples. Let's use that little my data set that I created earlier. And if I just print it using the defaults, so I haven't slapped any formats on, this is what you get. So SAS recognizes that this variable x really doesn't have any decimal, nor does y. Amount does, and it rounds it to 2 decimal places. Now we can slap some formats on. So let's say we want 2 decimal places on x. So if I print that as a 4.2, x will now have 2 decimal places. There's not much to show because there's, it's always zeros, but it gives me the zeros since I asked for them. Likewise, I'm going to display y as 3.1, so that means give me 1 decimal place. And let's slap a dollar format on amount, and it's displayed accordingly. So hopefully you're getting a sense for what these formats do. These formats are especially important when you have dates, any sort of date variable. So let me first tell you a little bit about dates in SAS. Dates in SAS are stored as numbers. The numbers represent the number of days that have elapsed since January 1st, 1960. So January 1st, 1960 is day 0. January 2nd would be day 1, and so forth. It's similar to SPSS. Just for reference, SPSS, recall, the start of time for SPSS was on October 15th, 1582, and SPSS stores it in seconds rather than days. SAS uses days, and the start of time is January 1st, 1960. So let's go back to that little example data set, and I printed it. I'm going to use an ID statement. The ID statement is not especially necessary in this context because my printed line is not that long. One thing that this causes is it gets rid of the obs equals, or the observation number. So back here when I printed something, it gave me the obs number, which was identifying the record. Here, the name is going to identify the record rather than some observation number. In the previous page, I got rid of it with this no obs option. So here's another Christmas tree ornament that we can hang on it. That's another way to suppress it, but the records are not identified by anything, whereas here it's going to be identified by the name. Okay, so we printed this. Joe has a birthday of 22 January 1960. Now I'm going to reprint this data set The only thing I'm going to do differently is I'm going to slap a best format on birthday. So best is going to cause us to print it as a number. Let's look what happens to Joe's birthday. It shows up as a 21. Remember, January 1st, 1960 is the start of time, so that is time 0. January 2nd would be 1. Therefore, January 22nd is day 21 in time. You might wonder, what do you get if you go backwards? So what is December 31st, 1959? Well, that is -1. So those are that's how SAS stores dates. So the 15th of August, 1981 was 7,897 days past January 1st, 1960. Let's do a few more things. Let's say you don't like displaying your dates this way. Instead, you want it day, month, year. So that's the way people often write it in Europe. In that case, you just slap that format on. The 10 there says I want to put 10 characters. And so sure enough, now it's 22/1/1960. Let's say you want month, day, year, but you don't want the 19. You want to suppress the first 2 digits. So the way to suppress those first 2 digits is to say, only give me 8 characters. And so that's how it's displayed. Another thing that's very useful, sometimes you get this data set that has a bunch of transactions in it, and it's over a 5-year period. You don't want to look at all 365 days times 5 years. It makes very long output. So sometimes you just want to round stuff to the nearest month. So I love this format. Month, year, 7 displays it as this. So it just gets rid of the day part. And so it's a nice way to form bins when you're looking at any sort of time variable. Let's move on to the where statement. So the where statement, remember, restricts which rows you look at. So let's go back to example, and up at the top I printed the whole thing. Now we can slap a where statement on, or hang a where statement ornament on this Christmas tree, and let's only print observations where their income was strictly greater than 100. Therefore, Joe should not be included. You'll see that Joe only has an income of 100. And here's the corresponding output. We're going to talk a lot more about these logical expressions. So income greater than 100 is called a logical expression, and we'll have more detail on that in a week or two. But I'm going to give you a few examples of some other things that you can do. You can also write expressions like this, where income is sandwiched between 110 and 125. If we go look upstairs, the only person who's in that window is Fred, and sure enough, only Fred is then printed. You can also do where statements on strings. So the name is a string. We could say, just show me Mary's record, where name equals Mary in quotes. So you can use single or double quotes, doesn't matter. And sure enough, you only get Mary. You can do stuff on dates. So if we wanted everybody who was born before, strictly before January 1st, 1975, this is the way you would write it. So quote 01 Jan 1975, end quote D. That unquote D indicates that you're specifying a date constant. And so when you do that, sure enough, you get only Joe and Mary, since they were the ones born before 1975. Another very useful expression is in. So if you said something like this, where name is in this set, Mary and Joe, well, there you go. You get Mary and Joe appearing. So that's the where statement. Another thing that you will often want to do is to change the sort order in a data set. So we do that with proc_sort. So I'm going to show you what my data looks like before the sort. So we get red, green, and blue in that order. Now let's say we wanted to sort this by color. In that case, blue would come first and red would come last. The way we would do this is with proc_sort. So proc_sort, data equals my data, and I'm going to output this to a temporary data set called my data2. We're going to sort by color. You got to have a by statement with sort, and then run. Here's what you get. So we've sorted by color. Sure enough, blue comes first, then green, then comes red. Now, the out equals is optional. So if you omitted the out equals statement, SAS would just overwrite what's in my data, and that may be fine for your purposes. So when you create a new data set, you're using up additional space, and that hogs up resources. So you may wish to just overwrite your original data set. Sometimes you want to change the sort order. You do that with the descending command. So you insert descending before the variable name. So if I sorted this where I wanted X descending, all right, then green's going to come first since that has the largest X value, then blue, and then red has the smallest X value. This is entirely equivalent to SPSS's sort cases. So data sort cases is the SPSS equivalent. Let's talk about the by statement now. So the by statement is equivalent to the split file option in SPSS. So it just repeats whatever you want to do by that variable, or it splits up the file by that variable and repeats the analysis. So now let's go back to the nonprofit data set that we've been playing with. I'm going to sort it. Let's sort it by two variables this time. We'll sort first by ID, then by gift date. And if we print that, here's what you get. Now I'm going to put the obs equals up here. So that means just give me the first 20 observations. We'll suppress the observation. I could have stuck that as an ID variable, and that would also get rid of no obs. And this is what you get. So what you'll see is that customer 18 made 2 donations. He donated something on 20th January for $10, then gave $5 later. Customer 935 made 3 donations to this charity. Customer 1347 looks like he made about 4 donations. Okay, now I'm going to print this a slightly different way. We're going to add a by statement. So we want to print this by ID. Here's what the SAS output looks like. So it gives us a chunk of output where the donor ID is Mr. 18. And what you're going to see is that you only get those 2 observations with that. Now I also included a sum statement, and by including that sum, it's going to give me the total amount that customer 18 spent or has donated. So $15. That's in essence customer 18's monetary value. Then you get another chunk that shows the information for customer 935, 1347, and I ran out of space, but this output carries on, showing you all the records that I showed over here. This was all in the same SAS program, so the options obs equals 20 also applies to this print as well as this print. Okay, you should work on the exercise on the next slide and view the solution as needed.